Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have discussed what do we mean by the emulsion polymerization, and we have discussed its concept with the clear image and animation. If you have missed that video, you can find it in the I button over here. Now, having said that, in this session, we are going to focus on the different advantages and disadvantages of the emulsion polymerization techniques. You can see here, higher molecular weight polymer can be made with the faster rate in this emulsion polymerization. Since this emulsion polymerization take place inside the micelle, we can produce polymer of the higher molecular weight and at the much faster rate than the suspension polymerization. The second advantage of this is at the continuous water phase is excellent conductor of the heat that allows the heat to be polymer molecule contained within the particles. So water allow to absorb all the heat that is generated in this exothermic reaction of the polymerization process. So again, this advantage of the heat transfer can be achieved with the water. So it is the method to increase the rate of the many polymerization reactions. Now, since polymer molecule contained within the water, viscosity remain close to that of the water and it is not dependent on the molecular weight. So entire reaction mixture having lower viscosity, or we can say similar to the water, and water is not that much viscous. So we can easily agitate, or we can easily transfer, or we can easily achieve mass transfer at the higher rate with such type of the techniques. This method is highly suitable for the free radical polymerization techniques, right? So this is one more advantage, that this technique is particularly very much suitable for the free radical polymerization that we have understand in the previous chapter. So this was all the advantages of the emulsion polymerization. Now let's just discuss what are the disadvantages of this particular method. With the isolated polymers, right, with the isolated polymer, water removal is very much energy intensive. So with this method, we are going to get polymer with the water. So to remove water, we require different type of the energy intensive techniques. They are usually designed to operate at high conversion of the monomer to polymer, right? So with this method, we are going to require high conversion of monomer to the polymer. So which again increases the capital cost and operating cost of entire system. It may result in significant chain transformation of the polymer. So this emulsion polymerization technique is not that much stable, right? We need to provide one stabilizer to the emulsion in the form of surfactants. So if we supply low amount of the surfactants, we can get the different chain of the polymer. Now surfactant and other additives still remain in the polymer, right? So we are adding surfactant and different additive in this technique, so they can still be in the form of the, so they can still remain in the product polymer. So their purity of the polymer can be reduced. So with this emulsion polymerization technique, we cannot produce polymer with the high purity. There will be some amount of the contamination either in the form of surfactants or in the form of additives. So this was all disadvantages of the emulsion polymerization technique. Now let's just quickly discuss what are the application of this thing. You can see here, this is the most widely used technique for the manufacturing of polyvinyl chloride. So majority of PVC is being produced with this emulsion purification technique. Though it is highly energy intensive technique, but it also can be useful for many polymerization techniques, right? For producing many polymers. The polybutadiene and polyvinyl acetate and lastly polyacrylides are the different polymer that can be produced with the emulsion purification, with the emulsion polymerization technique. So you can say that this emulsion polymerization technique is superior to all the polymerization technique. But again, it is energy intensive polymerization technique and which is not suitable for all the products. So this conclude all the polymerization techniques. Now we will discuss the comparison of different polymerization techniques, right? So now you can see here, starting with the bulk polymerization, we have studied that the bulk polymerization is often lead to the hazards because the heat associated with the chemical reaction taking place in the bulk polymerization is very high, and the dissipation of this heat is very difficult with the bulk polymerization. So as you can see on the screen that this bulk polymerization often real to the hazards. The thermal conductivity of monomer and polymer are very low, and the viscosity buildup limit the heat transfer. So as we have already discussed in the bulk polymerization technique that the thermal conductivity of monomer and produced polymer are very low. So we can say that they are not good thermal conductors. And not only that, the viscosity effect of this bulk polymerization process is very high, which means we will have lower heat transfer and mass transfer, and that can be lead to the explosion as well. Right now, the removal of unreacted monomer from the final product is also very difficult in the case of the bulk polymerization. Then, however, the level of impurity can be held down by using low initiator level. So with the bulk polymerization, we can get pure form of the polymer, right? We can decrease the impurity inside the monomer by increasing the level of the initiator. So these are the some points that can be used for the comparison purpose of the bulk polymerization. Now if we discuss about the solution polymerization technique, and if we compare the solution polymerization technique with others, we can say that this solution polymerization technique offers easier temperature control. So we have seen that this solution polymerization technique offers better thermal conductivity and better thermal control compared to the bulk polymerization, because in the bulk polymerization the product produced is in the solid form and which accumulated at the bottom of the reactor and which ultimately increases the viscosity, right? But in the case of solution polymerization, produced product is also in the liquid state. This is why these viscosity effect are not that much significant in the case of solution polymerization, and that can be lead to the better heat transfer and mass transfer operations. So there are basically two reasons why this thermal control is very much easy with the case of solution polymerization. This is because of added heat capacity of the solvent, right? So in the solution polymerization, we are going to use one solvent. So this solvent itself act as the added to the heat transfer, right? It will also facilitate the heat transfer, and it will have higher heat capacity. And the second reason behind this good thermal control of the solution polymerization is that the lower viscosity. Since the product produced is in the solid form, so it will not increase viscosity significantly. That's why we will get a solution of a uniform mixture. This is the reason why we are calling this solution polymerization as the homogeneous polymerization technique. And with this we can achieve higher thermal control of the reaction, right? The removal of the last traces of the solvent and unreacted monomer can be difficult. So to remove this solvent, or we can say last monomer, from this entire solution of the reaction mass is relatively very difficult, and hence this removal of the solvent is very difficult for this solution polymerization process. Now, the level of impurity can be very low since the initiator residue can be extracted. So, with the case of solution polymerization, similar to the bulk polymerization, we will have polymer of higher purity. Since we are not using any kind of additives and any kind of other materials, this purity can be increased by manufacturers by using this solution polymerization. In fact, the unconverted initiators can also be easily extracted out from the entire reaction mass. So this was the small comparison between this bulk polymerization and the solution polymerization. Now let's discuss about the suspension polymerization and emulsion polymerization. Both the methods can be referred for the tag of heterogeneous polymerization techniques. Right? You can see here on the screen that the suspension polymerization is essentially a bulk polymerization carried out in the droplets. So it is very much similar to the bulk polymerization. But the only difference here is that this entire bulk polymerization is carried out in a small droplet of the monomer. So we can say that this is the advanced version of the bulk polymerization. So it will have all the advantages of the bulk polymerization, but it also has some of the disadvantages, such as the temperature control can be complicated by the unstable nature of the suspension. So these are the some comparatively points that we can discuss on the suspension polymerization. The agitation is again very critical with the suspension polymerization. As the viscosity within beads increases, the reaction rate increases suddenly, and this leads to the surge in the heat generation, which does not usually occur in the solution or in the emulsion polymerization. So now you can compare here the suspension polymerization with emulsion and solution polymerization, as the reaction rate is very much high in this technique, which occasionally lead to the sudden increment in the reaction heat. So this reaction heat is become uncontrollable and it will lead to the explosion, which is not the case with the solution polymerization and emulsion polymerization, right? So this is the comparative points. Now, however, the viscosity of the continuous phase, that is your water phase, does not changes during the reaction. So we can say that in this suspension polymerization, viscosity of the solution remains more or less same before and after the reaction, so that heat removal from the reactor is easier than the bulk polymerization. So as in the case of bulk polymerization, as reaction proceed, viscosity continue to increase. But in this suspension polymerization, the viscosity remains more or less similar to the initial stage, so that we can easily remove heat from the reaction mass. So this is advantage of the suspension polymerization. Now, monomer recovery parallels that in the emulsion polymerization. Polymer recovery is simple and usually lead to the low impurity level than the emulsion polymerization. So with the suspension polymer, we can achieve higher level or higher grade of the polymer. That means we can achieve higher purity of the polymer comparatively emulsion polymerization technique. Now, having discussed this, let's just move to the last technique of the emulsion polymerization. As you can see here that the temperature control is more convenient in the emulsion polymerization. So this technique offers better temperature control than the all other techniques. We can easily control heat associated with this polymerization reaction. Now, because the viscosity changes are very little with the conversion, also the thermal conductivity and specific heat of water are high than those of the organic solvents. So, in the emulsion polymerization, we are going to use water as the solvent. And we very well know that water has the higher thermal conductivity and it also has higher specific heat, right? So, we can use this water as the heat transfer medium, so that we can easily remove all the heat associated in the chemical reaction, right? So we can easily control this exothermivity of the reaction with the emulsion polymerization technique, and that is the major advantage of this emulsion polymerization technique compared to the other techniques. However, impurity level are very low, rather high, because of the surfactants and coagulating resistance are much harder to remove. So with this technique, we are not going to get pure form of the polymer. This polymer will be contaminated with different type of the surfactants and other additives, which means it is the disadvantage for the emulsion polymerization technique, as the removal of this additive and the surfactants is very difficult for this polymerization. The polymerization reaction rate is higher than the other polymerization techniques. So with the emulsion polymerization, we are taking we are carrying this polymerization reaction inside the micelle, which increases the reaction rate by many factors. And we can say that this emulsion polymerization technique provides much better reaction rate than the other techniques. So this concludes the entire chapter of the polymerization techniques. Now let's just quickly revise what we have gone through throughout this chapter. We have understand why these polymerization techniques are different from the polymerization reactions. Then we have seen that four different types of the polymerization techniques. Starting with the bulk polymerization, then we have discussed the solution polymerization, then we have discussed what do we mean by suspension polymerization, and lastly we have discussed this emulsion polymerization. We have discussed advantages and disadvantages of the all techniques, right? In fact, we have seen what are the application of these different polymerization techniques. And in the last section, we have compared all these four polymerization techniques together, right? So this chapter is again very important for the exam point of view. Any one of the polymerization technique can be asked for your university exam. And they can also ask to compare one polymerization technique with others. Now, we will conclude this chapter and we will see you in the next video. Till then, keep watching, keep learning. Thank you.